Okay, everybody, what we're going to do is we're going to be building this board, the components of this board, which goes into the Mini Expander shell. So let's get this out of the way. Let's jump right into it. Alright, so here's the main board, front side, back side. Very first thing we need to do is to cut off these control pad interface boards. So what you do is you get very, very close, clip them there, and be careful because they will go flying. And we'll do the same thing on this side. Clip them there, and then you'll save these for the control pad part of the build, but we're not going to do that right now, so we're going to set them aside. And then what I like to do is take a little emery board or a little piece of sandpaper and just kind of take the sharp edge off of that, piece of circuit board there, a little piece of fiberglass edges that might be sticking up. Make sure it looks good. That's good. Alright, so that's the board. Alright, the way we go through this is we build from the lowest level components, the shortest components, and that's going to be the wires, the resistors, and a couple of these small capacitors. Then we'll do the chip sockets, here, 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 and here. Then we will add the bigger capacitors. Then we'll add the transistor, this larger electrolytic capacitor. Then the last couple things we'll do is we will put on the serial ports, the expansion ports, and then we will put the actual chips into the sockets after we're sure that everything looks good. So let's get started. We're going to start off with the wire is probably the shortest of all of them. So what we're going to do is, here's our wire. And again, if you've already got this wire, you don't really need to buy a whole new spool of it. This is a good quality spool. You'll have lots more left over after you're done with this, so no need to get crazy about it. This is solid core wire, which is kind of the opposite of stranded. Rather than having a bunch of little pieces of metal through the wire, it's just one solid piece, and you can tell that because it's less floppy. When you bend it, it actually stays in place. And then we'll set that aside because we don't need it anymore. First thing we're going to do is I go about 1/4 of an inch off of each side of this long wire. So there's 3 wires here, this wire, and this wire. So largest, medium, smallest. So we're going to go about 1/4 of an inch on either side of this wire. Alright, next thing we're going to do is we're going to strip the wires off of this guy. I have a handy-dandy quick strip. So take this guy, and we're going to bend its lead down. We're going to set it into the wire slot on one side, figure out where that is, and then we're actually going to trim to length here. Set this up there. We're going to not clip it, but put a little indentation there. And the blue plastic sheeting, or the blue plastic insulation around it, turns a little bit white so I can see where it's at. So I'm going to pull that wire off as well too. And then just like I did with the other one, I'm going to bend this wire down in place. So that's our first jumper wire. Perfect. Looks nice. Alright, that's one. Perfect. And there we go. So there's 1 wire, 2 wires, and then the 3rd wire. Alright, so what I'm going to do is I'm going to put a little bit of clay hold these two in place, and I'm going to hold this one in place. Hit it with a little bit of flux paste. And we're going to get these soldered into place. Alright, I'm looking really close at the edges here to make sure there's a good dome on them. And now, wear your eye protection. I'm going to trim the ends off because the little pieces of wire will go flying, so protect your eyes. Alright, and then I like to kind of redome those a little bit. So there are our 3 wires. Alright, next up we're going to do the resistors. So here is the 470. And we have a yellow, purple, black. So we go yellow, purple, black, black. And it is indeed 470K. Alright, so that one's good. Next one up is our 4.7K. Last but not least, 10K ohm resistor. Not too bad. A little bit of flux paste here. Wires and resistors. Next up, we're going to do our small capacitors. So there's our short caps. Let's do our medium-sized caps. There are 1, 2, 3, 4, 5, 6, 7 of them. And just make sure, quantity 7 of the 0.1 microfarad. So these are the microfarads. They're here, 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 and here. These are the balance caps to make sure that you get a consistent 5 volts on the input pins on all of these chips, which is, for the most part, up here. I think on this one's and on a different one, but on all the logic chips, it's to balance out the power. So we're going to flip it over. Alright, next up, we're going to do the choke. And I'm not really using a choke. I'm going to be using a ferrite bead for that. A ferrite bead is basically a way to filter line noise. If you want to, you can just put a wire through it as well too. This was more of an FCC sort of a thing than it is practical filtering. But since you're taking all of these signals out into an external piece of plastic, that's probably not a bad idea. The problem is the little coil-wrapped chokes that that came on the stock unit are really difficult to find. So first of all, let's put the electrolytic capacitor. Negative is on the back side, so follow the things. The little dimple here, which is shown on the silk screen, is this way. Let's put our choke into this thing. It's shown as L1. I'm going to do a little stylistic thing here because this choke is actually a little bit bigger. than the old one, so we're going to do the stylistic where one end is going to go down like that, and the other is going to tent up a little bit. And there's our filter. Now let's put the transistor on. Now the transistor on the original circuit board is a little bit harder to find. And again, this transistor is being used, it is a 3904. So what it is being used for is to amplify the sound coming off of the board. If you use the old stock, if you don't use a 3904, if you use a 1402, which was the original one, you have to turn it around. So this silk screening is shown for this 3904. That's why it says TN 3904. And it will work. You kind of splay the legs front to back a little bit. But if you're using the old one, you need to turn it 180 degrees. And if you take a look very closely on the back, it actually shows within the circuit board itself, emitter, base, collector. And when you're using it this way, the left one is the emitter, center is base, and the right is the collector. So it's right. But on the old original 1402, you actually need to spin it so that it's this way, not this way. Anyway, if you use the standard bill of materials, you'll be fine. Yeah, looks good. All right, transistors on there. All right, all the passives are done. Now let's put some chip sockets in. Next up, let's do these two sockets for the 244 chips. Okay, so those two sockets are done. Okay, the last of the sockets is the 40 pin for the sound chip. Good. All right. We have our sockets. We have our passives. We have our capacitors. Next thing we're going to do is we're going to put in our sockets. Now these are important. These are, what is it? TE connectivity. So the part number is 5530843-4. The part number from DigiKey is A31717-ND. They also have a right angle version of this, which is what would go on the motherboard. These are important because they don't stick up too high and they're not too wide. These are non-directional. You can either put them in this way or you can spin them 180 degrees. And again, these are currently the tallest items on the board, so there's no need to putty them up. And let's just get these right on here. Here are the DB9 serial ports. Very cool. Now, when they come on the Aquarius motherboard, this piece has been taken off. There's really no need to do that. It protects them, keeps them safe. Now, before we put these on, let's talk about a couple of options. There are holes that are about this size out of the back of the plastic, both the original stock and the 3D printed version. If you didn't want to buy these, you could do a couple things. First of all, most of you are going to be getting a joystick extension cable that has a male connector on it and then a female that is actually the end of the joystick. You're going to be cutting off one end anyway to solder to these control pads. So you might as well use the other one if you don't want to buy one of these. Solder it to the pads and then trail the male version out of the port. That's one way to save, 15 bucks or so a piece on these guys. The other thing you could do is you could solder the joysticks directly to these. Now that's kind of a pain in the butt because then if anything goes wrong with the joystick, you would have to go in and desolder it, or you would have this long trailing set of joysticks hanging out after it, and that's no fun. So we're going to use these. Again, for me it was worth the 15 bucks. They look great. It's great that they're still manufacturing these parts, and there's a very satisfying snap on these units as they go into place. All right, I think this pin's bent. So we're going to snap them both in place. They have what's known as board lock items, and each one has about 9 pins. So that's it. That is the soldering for this particular board. So before I go and put the chips in, I'm going to do a little bit of cleanup. Now the front of the board looks great. I'm going to show you what I use to clean up the boards. Let's see here. I use this in arcade cleanup. It's called Crud Cutter. You could also use Mean Green. It works well too. I just happen to like this particular product because I'm familiar with it and I know that it's generally gentle on my components. So again, not much flux on the front. It's pretty clean. So what I'm going to do is I'm going to put a misting of this Crud Cutter on the front and put our putty there, and I'm just going to go all over the pads that I soldered previously. We're going to kind of get this oily flux off of here. Now the flux that I use is non-corrosive, so it shouldn't be a problem, but not all fluxes are quite as gentle on circuit boards. So we're going to take this, mop some of that up, and notice we still have a lot of the suds, because this is a pretty strong detergent, and if you leave it on your hands it'll actually start to break down the oils in your skin, so don't leave it on your skin too long without taking them off. Washing your hands with soap and water. And speaking of soap and water, that's actually going to be the next thing I'm going to do. I've got most of the suds cleaned off. Before I put any circuits on here, I'm going to go ahead and get some of that off of there. Make sure it's nice and clean so we've got a pretty board. So that's it for this one. I'm going to go clean this off with some soap and water, and the next step is we'll populate this with some chips. Okay, and we're back. You can see we've got our board here. It's actually got some water on it. Wipe it off. This is an anti-static surface. This is a piece of slate marble. It's actually grounded to the frame. I'm grounded, so I'm sure people will be screaming in the comments, you should have a proper anti-static. Yeah. I'm sure when you do yours, you'll be fine. So this is the flip-flop. To the first socket. That's that one. So that's our 74. Next, I believe, is our LS30, not 330. And that goes in this first lower socket. And we're going to put this one there. Next up we have our 244s, which are right there. Socket, or the chip notches up at the top. Make sure that is in. Looks good. Edge notch. Make sure we haven't bent any legs out. Good. We've got a 6-channel inverter. The 04 goes right here. Notches at the top. This is the 04. Again, double check to make sure we haven't folded any legs. Looks good. And last but not least is an 02, which is a NOR gate. Pop that one back up. There we go. Legs look good. So we've got a 30, a 4, a 2, and a 74. All the notches are at the top. All the notches are at the top there. Let's do our sound chip. Now, this came from one of my older, damaged Mini Expanders. So this is an original General Instruments chip. The legs look good. They still have a little bit of solder on them, but generally they're pretty clean. They don't need to be cleaned up. I've straightened the pins. Notches at the top here, the opposite side from the Pokemon ball or whatever that is. We're going to gently rock it into place. And there we have it. We have all the components in place. Let's take a look at our plastics and see how they fit. Looks good. Let's roll it in place here, fit it into the slot right there, and then that's it. We have access to our ports. It's a little tight at the back, but that's something we'll have to deal with in the actual 3D part of it. So not a whole lot you can do to make those any shorter. Those are the shortest ones that are possible. Okay, here's our assembled cartridge, Mini Expander setup. We have 2 joy pads or control pads plugged into it, and let's turn on. Everything's working fine. Let's go down to the Mini Expander diagnostic. And we're going to go through the tests. Good. Our expansion RAM is good. So it is reading the RAM cartridge. Sorry, I had the volume turned down. Good. Okay, so that works. We'll accept that result. Test each of the buttons. Okay, the left controller is working. We'll pass that test. And let's test the buttons over here. All working. Cool. So we see that the Mini Expander that we built is working.